You know, everything we use, from the phone in your hand to the zipper on your jacket, it all comes from the earth. But we almost never think about what those things are actually made of, right? Well, we're about to dig into the hidden materials that literally power our world. And our journey is going to start in a place you would never, ever expect. So, think back to this morning. You brushed your teeth, I hope. But have you ever stopped to wonder what you were actually scrubbing them with? I'll give you a hint. It's a whole lot more than just some minty flavored goo. Okay, get this. The stuff that actually does the cleaning, those are abrasive minerals like silica and limestone. That fluoride that keeps cavities away, it comes from a mineral called fluorite. The reason your toothpaste is so bright white is thanks to titanium oxide. And hey, if it sparkles, you're looking at tiny flakes of mica. Oh, and the plastic tube in your toothbrush? Yeah, those come from petroleum. It's basically an entire mine's worth of stuff in one little tube. That whole toothpaste example is just wild, and it perfectly shows how much we rely on minerals for, well, everything. But to really get a grip on their role in our lives, we gotta understand what they are in the first place. So, what even is a mineral? The most important thing to remember is that it has to be a naturally occurring substance. We don't make it in a lab. It's the stuff geologists find in the Earth's crust, and it's like a history book of our planet, right down to its unique chemical fingerprint. But hold on, if minerals are just part of the Earth's crust, why can't we just, dig anywhere and find them? Well, it's not that simple. Finding them in amounts that are actually worth mining, now that's the real challenge. They don't just show up randomly. They form under very specific and special conditions. So minerals tend to show up in a few key ways. Sometimes they seep into cracks in rocks, forming these rich veins of metals like copper and zinc. Other times, they get squished into huge horizontal layers. That's how we get massive beds of coal and iron ore. Then, you've got minerals that are just the stuff left over after surface rocks wear away. That's where we get bauxite, the key ingredient for aluminum. And finally, some of the good stuff gets washed down rivers and ends up settling in valley floors. Geologists call those placer deposits. Now, for our purposes, we can pretty much group all the metallic minerals into two big categories. On one side, you have ferrous minerals, which is just a fancy way of saying they have iron in them. And on the other side, you've got non-ferrous minerals, which, you guessed it, don't have iron. Both are super important, but those ferrous minerals, they are the absolute foundation of our entire industrial world. There's a very good reason people call iron ore the backbone of industrial development. I mean, think about this. It accounts for about 3/4 of the total value of all metallic mineral production. To put it really simply, without iron, the modern world as we know it, well, it just wouldn't exist. Not all iron ore is created equal. You've got magnetite, which is the really good stuff, up to 70% iron, and it has these awesome magnetic properties that make it perfect for the electrical industry. Then you have hematite. It has a bit less iron, but it's the one we use the most, just because of the mind-boggling qualities we go through. But here's the thing. Getting all these materials out of the ground, it is not easy. And it's definitely not without consequences. There's a pretty steep hidden price we pay for all of this progress. 1%. That's it. Let that sink in. Out of the entire crust of the Earth, only one tiny percent has mineral deposits that are concentrated enough for us to actually mine and use. This one number really hammers home a critical point. These resources are finite. They are non-renewable, and we are burning through them way, way faster than they could ever form again. And the process of mining itself has this really dark, two-sided impact. For the miners, there's the constant terrifying risk of collapsing mines and fires, not to mention the long-term health problems from breathing in dust and toxic fumes. And for the environment, mining can contaminate water sources, and all the waste that gets dumped just destroys the land and pollutes rivers. It's a heavy, heavy price for both people and the planet. Okay, so you've got the raw minerals, but turning that lump of rock into the things we use every day requires one more absolutely essential ingredient: a massive, massive amount of energy. When it comes to energy, we're basically working with two different playbooks. In one corner, you've got our conventional sources, the finite fossil fuels like coal and oil that we've been relying on for centuries. And in the other corner, you have the non-conventional, renewable sources, things like harnessing the power of the sun, the wind, and even the ocean's tides.
Let's take a quick look at coal, which is our most abundant fossil fuel. It's not just one thing, it's the end product of millions of years of heat and pressure. As you can see, it kind of starts out as this soggy, low-carbon stuff called peat. Give it some time and pressure, and it turns into lignite. Even more, and you get bituminous coal. That's the kind we use the most. And finally, if it gets cooked long enough, it becomes anthracite, which is the highest quality, hardest form of coal out there.
Now, being so dependent on these finite fuels has created all sorts of problems, which is why we're scrambling for alternatives. And solar energy is a huge one. With what's called photovoltaic technology, we can turn sunlight straight into electricity. It's a total game changer, especially for rural areas. Of course, to build those solar panels, you need a whole other set of minerals, like silica and silver, so our energy future is still tied directly to our mineral supply. Then, of course, there's wind power. It's a really simple idea, but incredibly powerful. You just use the wind to spin these giant turbines, and boom, you've got electricity. But again, those turbines are engineering marvels, packed with minerals. We're talking tons of steel and zinc, plus super powerful rare earth magnets to make them work. And get this, we can even pull energy right out of the ocean. Tidal energy is pretty cool. You build dams across inlets, and when the tide rolls in and out, the water rushes through a pipe, spins a turbine, and creates electricity. But again, all of that requires enormous amounts of concrete and reinforced steel to build. So when you put it all together, it brings us to this huge critical crossroads. Our entire world is literally built from materials that are running out, and it's powered by energy sources that are also finite. The path forward isn't just about new gadgets, it's about a whole new way of thinking. You know, a truly sustainable future really seems to stand on two main legs. First, we have to get really serious about energy conservation, which is just a fancy way of saying we need to use less of it. And second, we have to hit the accelerator on our switch to renewable energy sources. There's this quote that just says it all perfectly. Energy saved is energy produced. Just think about that for a second. Every single time you decide to turn off a light, you're contributing to our energy supply, just as much as a power plant is. It's such a simple idea, but it has incredibly powerful implications. Which leaves us with this final massive question. From the stuff we use to brush our teeth every morning to the energy that lights up our cities at night, our entire modern civilization is built on materials that will one day run out. Knowing that, the question isn't if we need to change. The question is, how are we going to build the future?